So here's number 22 from the 2012 AP Calc multiple choice set. Non-calculator question here presents us with this function f of x, and then it asks us to find the absolute maximum value of this function. So if you're considering a function on its entire domain, there's not an interval specified here, and you're trying to find the absolute maximum, your maximum is going to happen at a critical number. So for this particular function, when we go to identify critical numbers, we're going to want to take a derivative of it. So you see I applied my quotient rule here. So I've got the derivative of the top, original denominator, minus original numerator, derivative of the denominator, and then all divided by the original denominator squared. This actually cleans up pretty nicely. 1 over x times x is really just 1. And then natural log of x times 1 is still just natural log of x. So we have a pretty nice derivative to work with here. Now, critical numbers refer to two different spots, places that the derivative is equal to 0, and then also places where the derivative is undefined. So you're going to have to analyze both of these. Now, when you look for when the derivative is equal to 0, this fraction is only going to ever equal 0 if the numerator is 0 and the denominator is not. So I set the numerator equal to 0. I added natural log of x to the right hand side, and then you'll see I exponentiated to isolate x. So I end up with e to the first on my left hand side as my one value of x that makes the derivative 0. Now this particular function is undefined at 0, right? Division by 0 happens with the function when x is 0. Division by 0 happens with the derivative when x is 0. Although the function's derivative is undefined at 0, it's technically not a critical number because it's not even in the domain of the function to begin with. So the sign chart for f prime here is going to look like this, beginning at 0, working to infinity. And the reason for that is because natural log of x as a component of the original function only is able to accept values that are positive. So the domain of the original function is illustrated by this number line right here. And I check the sign of the derivative between 0 and e is about 2.7, right? So I can pick a value like 1, and when I put 1 in place of the x, I get 1 minus natural log of 1. Well, natural log of 1 is 0. So I get 1 divided by 1 squared, which is going to give me a positive result. When I take a value that's bigger than that, if I take anything over here, I can take 3, I can take 500. 1 minus the natural log of 500 is going to be a negative value. Taking that negative value and dividing by 500 squared is going to keep it a negative value. So our function is increasing from 0 to e. Our function is then decreasing from e onward to infinity, and that indicates to us that our maximum value occurs at x equals e. You look at your options though, and e is not one of them. I probably would have expected it to be one. If you read the wording carefully here, what is the absolute maximum value of f? It doesn't say what's the x value where we get the maximum. It asks for the absolute maximum. So I'm going to have to realize from here, hey, I've got to toss e into the function and evaluate that function at this x value to determine the maximum function value. So when you evaluate the function at e, you get natural log of e, which is 1, divided by e, so we end up with 1 over e.